So welcome everybody to our next course round of the FDD3359 course on reinforcement learning. So many people are already here. Some people are not joining today, but we are in total 26 people this round. And it's really, really cool to see all of you here and wanting to learn about reinforcement learning. And we're also happy to give you a very special course this time with all the different specialization topics this year, given by Alexander, Hang, Alexi, Ali, and me. First, let's give you a round of introduction of who we are at this time in the course. This course is examined by Danica Kragic. She's a professor for robotics at RPL at KTH, so in the EECS school. And her research is on classical robotics, manipulation, computer vision, but also on machine learning, representation learning. She will be the examiner of the course, and she will also be there at the presentation day when you present your results. Next one, Alex, you want to give small heads up of who you are?
Yeah, it's very simple, everyone. I'm Alex, and I'm postdoc at RPL.
Next one, Ali. I think he cannot join today, but Ali is also a postdoc at RPL, and he's working on machine learning, reinforcement learning, and he's also a postdoctoral fellow in the WASP program with Stanford. And he will give you also some insights on the research he's doing. Hang?
Yes, and I'm Hang. I'm also a postdoc working at RPL, and my main research interests lie in data efficiency from control theory or and the learning for complex manipulation tasks such as deformable object manipulation.
Great, thanks. Alexi?
Hi everyone, my name is Alexi. I'm working on topics about formal methods and also human-robot interactions. I work on some inference techniques for formal methods. And for the course, I will be teaching some HRI and formal methods related topics to reinforcement learning.
Great. And my name is the last one. My name is Chris. I'm also a postdoc at RPL, and my research focuses on safety verification. So how can we ensure that the system is safe or behaves as expected and also is accepted by users of the system. And recently I tried to apply these kind of techniques to reinforcement learning. So with all of our 5 teachers, this time we want to give you an overview of reinforcement learning, but also how to use reinforcement in different areas of research. You are 26 people who registered for this course, and thank you for filling out again the poll that I sent around. We have a huge variety of backgrounds this time, from classical control to electricity to a recommendation system, exploration, and so on. So it's really cool to see such a diversity in the backgrounds this time. So far, what you have said is, when we asked you how familiar you are with reinforcement learning, we saw that almost half of you, it will be the first time with RL. Some other people regularly work with RL, and some others just did courses. We looked at our schedule and tried to accommodate for that, so that if you feel that there are some things that you need more explanations on, let us know. We will have question sessions in the beginning of each lecture, or just shoot us an email and so on, but we try to give you a high-level overview, but also enough details so that you can implement all the approaches. Here's an excerpt of the expectations that you provided to us about the course, and it's just copy-pasted from the poll. So you said you want to have a survey of state-of-the-art, work more on practical reinforcement learning programs, revise existing knowledge, having more implementation tricks, and getting a deeper understanding also of the theory background, not the classical. What you probably hear is, I execute an action in an environment, get a reward and state, and then I optimize a policy. But how is it actually done? How can you model these kind of systems? How can you constrain these systems so that they get the result you want? Also want acquire a toolbox for reinforcement learning techniques to strengthen everything, understand it in your research area, and to also have it for beginners. So far, we have designed the course that you get the technical introduction in the beginning, then more specialization throughout the course, and in the end, a lot of applications. And the second half of the course is designed to work with 2 other students in this course on applying the learned knowledge in a project that is defined together with us in your research area, where you get to know tools, where you can already apply certain things and then present the results to others. We hope that after this course, you will be able to describe the basic concepts and recent advances of reinforcement learning from different areas, that you will be able to explain reinforcement learning problems and their challenges, apply reinforcement learning concepts that we teach you to an existing problem formulation, maybe of your research area. And when you implement a reinforcement learning agent or you see a reinforcement learning agent paper, that you can analyze the RL performance that you see with respect to your problem formulation, but also what you see in the paper. And more advanced, we want to show you how you can assess how to constrain your reinforcement learning system to have certain properties and to improve the reinforcement learning system, for instance, the data efficiency and so on. And in the end, we want you to be able to implement a complex RL system for your own research, which will be the part of the project course or project part in the second half of the course. As already mentioned, this course has 6 credits. And in order to pass this course, we require you to work in a group of 3 students on an RL project that is applied to your research. So in the second half of the first part of our course, we will start to mingle you a bit so that you get to know each other and you can find good groups. And then together with your group and us, you will define what kind of research project you will work on. You have until the end of June, where we have a presentation day, to work on your project. And in this presentation day, you present us the results to the other groups, which is around like a 15 minutes presentation, and followed by a discussion that you moderate 10 minutes long on specific results that you say, for instance, how can we improve these results? What do you think? Is it what we expected given our research question at the beginning? Also, we want you to actively participate in the discussions of other groups. So just when there's a moderated discussion, also take part in these discussions. And in the end, submit your presentation and your code. When you pass this course, we will automatically sign you up at doctoral studies. So you don't need to register in LADOC. We will do that in the end with the list of past people. Daniel Zakagic will automatically send this to the Doctoral Study Center, and then you will sign up with your credit points. If you're from outside KTH and you need special things, just contact me at the end of this course and we will find a solution for you. Organization-wise, we will have a lecture that takes place every Wednesday. Today is the first one. It will be from 2 p.m. to 3:30 maximum. We will meet on Zoom. The Zoom link is here. And all the material will be posted on our public social page. A lot of people asked me already why we don't use Canvas. So Canvas is also a good system, but it's more for KTH. We have people attending today that are from outside KTH, and then the public social page is the easiest form that we can use. So just follow this link on this public social page where we post the lecture recordings, the lecture slides, and as well as other information. For instance, we have a page on the grading criteria, as well as a page on literature that we recommend. And if you have ideas on other, let's say, literature or tutorials, just send us an email and we will also post it on our social page. As mentioned, the group forming starts in the second half of the lecture part, which will be around the Easter time. The presentation day is to be discussed with you all, that you can all take part, but it's definitely the end of June before midsummer. The tentative schedule of the lecture so far is that Alex will give you a nice introduction to reinforcement learning in general in the first 2 lectures. Then Ali will continue with 2 lectures on offline reinforcement learning and meta learning. Hang will continue with data efficiency for reinforcement learning and control applications. And then Alexi takes over for constraint reinforcement learning using temporal logic constraints, as well as human-robot interaction reinforcement learning. Then in the end, I will talk more about enforcing safety constraints in a continuous reinforcement learning system, as well as how to correct reinforcement learning policies using a formal methods-based technique called shielding. Then we will follow with applications for safe, robust, and acceptable autonomous systems. And then Alex will close the lecture part on applications of reinforcement learning to chemistry and biology. So you will see more different applications here, and also not just the classical robot performs an action. And last thing is the presentation day, which will be the end of June before midsummer. We don't know yet if it's plus or minus 1 lecture, depending on the need that you have, if you want to have more explanation sessions, and if we might need to adjust some dates because of official KTH vacation days.